Hi, welcome to the second part of lesson 11.1. This one is a little bit less intuitive maybe than the square root method, and so I've got some steps written down here below on my whiteboard, and I've already got our first example written up here, so I will make reference to the steps as we work through the first example. All right, our very first question says, is A equal to 1? And if you recall, A is whatever that coefficient is in front of the x squared term. So here A is indeed 1. Step 2 says move the C, which means we need to take our constant, C is always the constant term, and jump it over the equal sign. So subtract 1. So we end up with x squared plus 4x equaling negative 1. And what I want you to do is I want you to add some spaces there in the back, because if you jump down to our steps a little bit, you're going to see that we're going to add something to both sides of our equation, and that's where we're going to put that number. All right, second or third step says we're going to take half of whatever the b term is and square it. So our b is a positive 4. Don't take the x. We're only talking about the number in front, the coefficient. And we're going to take half that. So over here off to the side, I'm going to take 4 and I'm going to divide that by 2. And I'm going to get 2 and I'm going to square it. 2 squared is 4. So that positive 4 is what I'm going to add to both sides of my equation. All right. The next step says I'm going to factor. So let's kind of rewrite this. Let's clean this up. You know, these two things can go together. Negative 1 plus 4 is going to be a positive 3. This side cannot be factored clearly, but this can. So when we complete the square, what we've actually done is we've created a trinomial on our left-hand side that can be factored. This is going to be a perfect square trinomial. So we need two numbers that multiply to 4, that add to 4, which is 2 and 2. So this is going to factor to x plus 2 times x plus 2. And on this side right here, negative 1 plus 4 is 3. I can rewrite this as x plus 2 squared equals 3. And at this point, it should kind of resemble some of the ones that we did in the square root method. And so right here it says, solve using square root method. So we do all this preliminary work to get to this stage right here. So now we can complete it by square rooting both sides. When you square root something that's squared, that's going to cancel that out. Don't forget your plus or minus in front of the radical. We're going to finish this problem up by subtracting 2. And so we have x equals negative 2 plus or minus radical 3. So from this step to this step is new, and the second we take the square root of both sides, we're repeating those steps from the square root method. Let's do the whole thing again. The good news is that there are some strange ones where we would end up with some fractions. We would have either an odd number for the b, or we would have a problem where a is not equal to 1. And due to some of our time restraints in our semester, I have chosen not to do any of those. So good news for you. All right, so this is a 1. Our first step is to move that c to the other side. So I'm going to add 4. So I have x squared minus 6x, put that space, 4, put that space. This guy right here is a negative 6, so off to the side, maybe up here, negative 6 divided by 2 is negative 3, squared is 9. So I am going to add 9 to both sides. This can be factored. It's always going to be something squared, x plus or minus a number that goes right there. Because this is a negative, we need two numbers that multiply to a positive 9 that adds up to a negative 6. Minus 3 and minus 3 will do that. Notice how this number right here is that number right there. And that will always, always, always be true. So after you half it, but before you square, the number that's in the parenthesis right there will always be the number that matches inside that parenthesis there. All right, on the other side, we have 4 plus 9 is 13. And we've gone all the way through these steps, and we're ready to do that last step there. Square root, x minus 3, because that breaks out, plus or minus the square root of 13. Move the 3 to the other side. There's nothing we can do with radical 13, so our final answer is 3 plus or minus radical 13. One more example, just to make sure you've got it. X squared plus 8x minus 9 equals 0. All right, you might notice if you look at this real quick, you could factor this. Even though you could factor, we're going to use complete the square just to show you how the numbers are going to work out. So, step 1, add the 9, x squared plus 8x equals 9. Add in those spaces, take that 8, divide by 2, we get 4. Notice it's a positive 4 because that came from a positive 8. When we square it, we get 16. So I'm going to add 16 to both sides. This can factor. A number that multiplies to 16 and adds up to 8 is 4 and 4, or x plus 4x plus 4. That number is that number, so once again those match. 9 plus 16 is 25. Take the square root of both sides. This becomes x plus 4. On this side we have plus or minus, and since 25 is a perfect square, the square root of 25 is 5. So this one's going to have a few more steps to it. When we move the 4 to the other side, we get x equals negative 4 plus or minus 5. And since this is not a radical, we're going to split that. I did one example, I think, in the square root method to show you. So we have negative 4 plus 5, which is positive 1. And we have negative 4 minus 5, which is negative 9. This section, this method of solving quadratics does come back in a different way, but I would familiarize yourself with the steps because when we learn to graph quadratics, this comes back in section 11.7. And so I would do this, I would encourage you to do the homework for the complete the square and some things like that. So hopefully you've got it, and good luck with section 11.1. Thanks.